Hello everyone. Before we really start our practical examples, I just want to explore polynomial regression because as of now we are very much familiar with linear regression. So if I just write it like this, so suppose y equal to, we have beta 0 plus beta 1 plus x1. This is more like a linear regression, right? Now, when we are talking about the multilinear regression, then we actually handle it like this: beta 1 plus x1, beta 2 plus x2, like this. Okay, so this is called the multilinear regression. Okay, but we can think about some polynomial regression also, and how that is looks like. First, let's see. So x1 plus beta 2 x1 square, like this. So this is the polynomial regression because we are doing the power, and that is sometimes this kind of functions give us the better results in the model. But the intention here to show you like this polynomial thing not always very helpful, especially like if I take the graph, like probably when m equal to 1, that's mean I'm considering this actually m equal to 1, the degree of polynomial. Here probably it's sorry, this is 2, this is 3. So in that case, when it is completely linear regression, then probably it's a complete straight line. But when it's m equal to 2, it will more like this. So you will get little bit more flexibility. So these are your data points, so probably it is fitting more. Here less number of data is getting fit. M equal to 3, probably it's getting more like this, and more informations are, more values are getting fit. But this is not always true, so we have to be a little bit careful. If you are considering about this polynomial regression, then you have to be a little bit careful on this thing. Actually, you cannot just simply increase it. One problem is there will be one stage when it will not at all fit. Probably your line will be like this, but all your value is like this, so it's a fail. Probably m equal to 6, it will fail actually. And why? Because let's consider this y-axis is actually on 10 to the power 6, because it's a million, right? We are predicting the house price, so it's on 10 to the power 6. And here it's a square foot, right? Square foot. So it's probably 10 to the power 3 or something. So here 10 to the power 4, 10 to the power 5. But after a certain limit, what will happen, this coefficient value, because beta 0 plus beta 1 x1, this value will be so small that it will be hard to calculate, and it will tell that okay, this features doesn't have any importance because this value is getting too small. Okay, so this is one thing we have to be very careful, like when we are doing the polynomial regression, especially this kind of thing. So you have to be a little bit caution about this, how we will increase, because one certain limit, if the scaling is not proper, but we can still handle this scaling problem just dividing it by 10 to the power 3. Then we can do scaling and then this problem can be solved. But still there will be a problem actually, because when we'll compare with your um, training error, so you will see the training error is actually getting down, but when you will think about the test error, what will happen after certain time, this will increase. So basically if we consider this like this, so let's consider this first line is my um, training error, and this line is my test error. Then we have to plot this, and we have to find out a sweet spot. So probably this is the perfect place. Up to this we can increase the polynomial, because after that, though my training error is getting reduced, but my test error is not getting reduced. So we have to understand this uh, sweet spot, and based on that you have to take a decision. So this is just to give a little bit of background, like if you are considering about polynomial regression, because we already spoke about linear regression, multilinear regression, but polynomial regression can sometimes give a good result, but you have to be careful like how long you will increase this power, like at x square, x cube, like this, how long you will continue. So that's the one thing you have to be careful, and that's you can judge by this graph. Like you have to plot a graph like a training error and test error, and then you have to find out the sweet spot actually, and then up to that you can increase your polynomial degree. Hope you understand this. I will continue in the next video. Thank you.